Today, we will be talking about adding and subtracting polynomials. One of the first things we want to break down are the definitions of common words that we'll be using to this point, such as a monomial, which we refer to as a term, is an expression that is a number, a variable, or the product of a number and one or more variables. A polynomial is the sum or difference of monomials. And the last one is monomials that have the same base. When they say base, they are referring to the number that is multiplied, the value that is multiplied, with the same exponent are said to be like terms. So what they mean by like terms, if at any point you have some variable, such as the term 2x, it does not matter what the coefficient is, as long as it has the same variable to the same power. So in this case, our variable is x to the power of 1. Another term for exponent is power. Or if you switch it up, where is the symbol that I need? Oh, not a script. Structure, not symbol. There we go. So for this term, we have 5x squared, or 5x to the power of 2. This would be a like term with any number times the same base, x, to the same power, or exponent. So these are the same or like terms, not same terms. They are like terms. Examples of unlike terms would be when the variables are different. So in this case, we have a variable x and a variable y. Since they are different since they are different variables, they are not like terms. They are unlike terms. Another example, the main one that you'll be covering today, is whenever you're dealing with variables or same variable base, but different variable powers. Oops. I'll get this down eventually. So in this case, as long as these powers, the superscript, are different, these are not like terms, so we cannot combine them, which is what we're going to go over next. When we add polynomials or subtract polynomials, we add the coefficients of like terms. Add or subtract. So whenever you're doing this, you want to make sure that you mark down alike terms. As you can tell, we have multiple x for a base, but we have different powers. We have some that are cubed, or to the power of 3. We have some that are squared, or to the power of 2. And then we have some that do not have the variable shown at all, a constant. So in this case, I marked them with matching colors and shapes to make it easier for me to combine the like terms. When you do this, you always want to start with the highest power of your variables and alphabetical. In this case, they're all the same variable with no variable at the end. The highest power is our cubed, so we'll combine those. This is a -6 plus 4 for our x cubed. -6 plus 4 is a -2. And this is our x cubed term. Now we can move on to the next power, the next set of like terms, which is 3x squared and x squared. The 3 plus the 1 coefficient adds up to equal 4 for the coefficient of our x squared terms. This will be properly read as 4x squared. And then our last piece, our constant, which should always go at the end, at the last part, is just a -3. So this creates a simplified polynomial. The proper way to read this is -2x cubed plus 4x squared minus 3. Now we can have our polynomial written across, or we might have some instances where it leads up to the earlier way we learned math, where they are stacked, they're vertical. This way is still the same. You want to make sure that they are matched up. I have my cubes together, so I know these are lined up. I have my squares together, these are lined up. So in this case, you follow the same steps. You still have -6 plus 4, which was a -2. In terms of our x cubed, we have our 3 plus 1 for our x squared. 3 squared plus x squared is a total of 4x squared. And then we have nothing to combine with the -3, so it stays -3. Now another part that we need to make sure that we pay attention to is parentheses. We would have to distribute to get rid of parentheses first, and to make sure that all the variables and powers match up when we try to combine like terms. In this case, there's no symbol in front of this. We know the parentheses is positive. The same for this set of parentheses. We have a positive symbol in front of it, so nothing is going to change. We can use all of these symbols. It's as if we do not have parentheses in the equation. So in this case, I need to mark down terms that are the same. Our highest x power, because alphabetically that is the first letter, is x squared. It is x squared y. So we need to make sure that we combine all x squared y terms. This is x y squared, so that is a different term. This is y cubed, it does not have an x, so that is a unlike term, and that is a constant 3. The next like term is in the other parentheses. Then we have y cubed again, and then we have a constant. So if we go through this, The only time that we saw x, y squared was this section. And let me get the symbol that goes with it to show that it is a positive 4x y squared. Our y cubed would be our next alphabetical variable and our highest power. So we have the negative 2y cubed, and we have the positive 3y cubed. And I have to get another color for this. Let's keep it simple. And then our constant, if we see, we have the plus 3, and we have the negative 4. So now that we mark this all up, we can combine our like terms. Let's go back to our basic color red. First was our x squared y. We have 3 plus 1 gives us 4 in terms of x squared y. Our next term that we said was xy squared. Alphabetically, it's our next one. We have just the 4xy squared. Because this is a separate term, we need to separate it with a plus or minus operator. It's positive, so we just put plus. The next alphabetical would be y cubed. So we have negative 2 plus 3, which is a positive 1. We can put plus because it's positive. We do not need to write 1 as a coefficient, so we can just write y cubed. And our last step is our constant. Since it has no variable, we can just do 3 minus 4, which is a negative 1. Or more specifically, it is 3 plus a negative 4, which would be a minus 1. So our simplified polynomial would be 4x squared y plus 4xy squared plus 3 cubed minus 1. Our last example. This time, our first parentheses is still positive, so that cancels out. But our next parentheses has a negative in front of it. That's going to change the symbol of every single piece here. That means that this becomes a positive once we use it. Make sure I have the right. Yeah, just making sure I use the right symbol. This will now become a positive. The negative becomes a positive again. Our positive will now be a negative. And yet again, a negative becomes positive. So in this case, whenever you have a parentheses, if there's a negative in front of it, you need to change the symbol of every term inside the parentheses. It'd be the same as taking this negative and multiplying each part. Negative 1 times negative a squared is positive a squared. Negative 1 times negative 5ab is positive 5ab, and so on. Now when we combine, I'll use a different color so we don't mix this up. Make this a little bit smaller. We have 3a squared with a squared negative 2ab with a positive 5ab negative 2b squared with negative 4b squared, and then our constant, negative 7 and positive 2. So in this case, I did use the negative in the middle, so I can just combine them exactly as is. Let's go back to our red and go back to the same size. In this case, 3a squared plus a squared would be 4a squared. The base stays the same, coefficient's the only thing that changes. Negative 2ab plus 5ab is a positive 3ab. Our next like terms is b squared, which becomes negative 2b squared minus 4b squared, which is a negative 6. Oh, this is going to be difficult, making these look different. Here, let's try to make this 6 look a little bit different. There we go. Only looks like a slanted b now. Negative 6b squared. And then our coefficients of negative 7 plus 2, which is a negative 5. So in this case, our simplified polynomial is 4a squared plus 3ab minus 6b squared minus 5. So in this problem, you needed to make sure that you distributed the negative throughout the parentheses, which means you are simply changing each term's sign from a positive to a negative and a negative to a positive.